Hi Algebra 1 and thanks for tuning in. Today we're looking at lesson 6.3 part 1, exponential functions, and we're basically just identifying them, what is exponential, what is not, and then we'll also evaluate some of them. You will need a calculator, so just make sure you have that with you, and we're looking for 7 things to go on our notes. The first thing we're going to write down is what an exponential function is, and there's a lot of stuff on this page, but I tried to make it as simple as possible. An exponential function is nonlinear, and it's in the form of y is equal to a times b to the x power. A cannot be 0, b cannot be 1, and b has to be bigger than 0. So all the examples you see today will have those indications. And then another thing to consider is how it changes. As the independent variable x changes by a constant amount, the dependent variable y is multiplied by a constant factor, which makes consecutive y values form a constant ratio. Let's take a moment to write this down. I know it's a lot, but it's very important that you write it all down. So let's pause here for number 1, write down what you see on the board, and then once you're done, click play so you can see how it's done. So the first part of your notes is basically just going to ask you, does the table or do these values represent a linear or an exponential function? If you look at the first one, you notice that x is increasing by 1, so we're adding 1 each time, and then y is increasing by 2 each time. Because we are adding for both the x and the y, we're going to say this is linear. Remember, exponential needs to have some type of multiplication with the y in order for it to be exponential. So we would say linear, both x and y increase by addition. With letter B, though, you're going to notice something different. Again, x is increasing by adding 1, but if you notice, y is increasing times 2. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. So we would say letter B is exponential because we have this going on right here. Letter Y is increasing by a multiple of. So anytime y is increasing by multiplication at a constant rate, you are going to say it's exponential. If it's increasing by addition, it is linear, and if it's not increasing by any of those, then it'd be neither. Keep in mind, addition can also be shown by subtraction, and multiplication can also be shown by division. Like you can multiply 1/2, and that's the same thing as dividing by 2. So here are 2 that you're going to try. Again, you're just going to determine if it's linear or exponential. Go ahead and pause the video so you can try that one on your own. And once you're done, click play to check your work for both 2 and 3. Alright, so number 2, we notice that it's increasing by 1 each time for x. And then for y, you can either say it's being multiplied by 1/2 each time. Multiplying by 1/2, though, is the same thing as dividing by 2, and that is totally fine because you're still multiplying technically. So we would say number 2 is exponential. Number 3, we notice that we are adding 4 each time to x. And then for y, we are adding a -1 each time for that one. So this one we would say would be linear because there's no multiplication for the value of y. Again, here are 2 more to try, numbers 4 and 5. Let's go ahead and pause the video and determine if they are linear or exponential, and just maybe show your work of how you got that or write a sentence for your explanation. Okay, so for number 4, we are adding 2 each time for letter x. And then for y, we are also adding 2. So this would give us a linear function. For number 5, we are adding 1 each time for x. And for letter y, we are multiplying by 3 each time for those values. So this one would be considered exponential. Okay. The next thing we're going to talk about is just what happens when you are given x values and you're asked to evaluate. So these are pretty easy. All you're doing is plugging in whatever you're given for x using your calculator to solve. So what I'm going to do is just rewrite my exponential function with the letter x attached to it. So -2 parentheses 5 to the 3rd power. In order of operations, it always says to start with your exponents. So I'm going to get 5 to the third, which means 125, and then multiply that by -2. I'm going to get -250. Same thing for letter B. Again, plug in your exponent. Noticing that letter B, I do get a negative exponent, so when I rewrite this, I'm going to rewrite it as 3 over 0.5 to the second power to make that positive. And then I would get 3 over 0.5 times 0.5, that's 0.25. And then I can actually go ahead and divide 3 by 0.25, and I get 12. So just make sure that you're simplifying all the way down for your answers for these. So here are 6 and 7. These are the last two in your notes. Again, these have 3 different values. Let's go ahead and try it when x is -2, 0, and 1/2. And then once you're done, click play to check your work. Notice that 1/2 is going to change it to a radical. So let's go ahead and pause here for now. Okay, for number 6, you have a few different values. The first one I did was -2. So we have 2 times 9 to the -2nd, which is 2 over 9 to the 2nd, which is 2 over 81. So that's your first value. The next value we'll have is 2 times 9 to the 0, which just means 2 because 9 to the 0 is 1. The last one we'll have is 2 parentheses 9 to the 1/2. Remember, 9 to the 1/2 means finding the square root of 9. So that's basically 2 times 3, which is equal to 6. Okay, so that's how you would do that 1/2 exponent. We're going to try number 7 now. Number 7 with your first value of -2. So we'll have 1.5 times 2 to the -2nd power. Again, that changes to 1.5 over 2 to the 2nd power. So we'll have 1.5 over 4. And then you can go ahead and divide that. You get a decimal of 0.375. Same thing is true for this 0 power. Again, remember, anytime you have a 0 power, that just makes it 1. So 1.5 times 2 to the 0 power is just 1.5. You can essentially just cancel that 2 to the 0 power out. The last one was kind of tricky because whenever you tried this one, 1.5 times 2 to the 1/2, that's saying 1.5 times the square root of 2. And the square root of 2 is irrational. So what you needed to do here was maybe use your calculator. You just type in 2 and then hit the square root button. And when you do that, you get a long number. You get 1.414. I'm just going to stop there. So then you would multiply that by 1.5. And you would get approximately, I'm going to round this, so equivalent to 2.12. So that one was a little bit trickier. You did need a calculator for that one. Just be careful with your irrational square roots and non-perfect squares. That's going to conclude our notes for today. Thanks so much for tuning in, and we'll catch you next.